Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is again from Momentum playlist description. Read it to know all the prerequisites and get the maximum from those 5 minutes that I would be talking. And basically they tell us that there is a projectile thrown at angle alpha, and they tell us that it's parabolic trajectory, and they tell us that this is a maximum point, and here this projectile separates into two different masses, so it's m and m, so it's 2m in the beginning, and then this is two parts that go independent from each other, but they tell us that this fly exactly back. One of them flies exactly back, and they basically want us to know what will happen with the second one. Basically they don't give us any speed, anything, but it probably means that it's irrelevant. Indeed it's irrelevant because everything will be cancelling out in our equation except of real numbers. You will figure out in a second what I mean. So, P equal constant, P is the law of conservation of momentum, the X is this axis, and we will be solving this at that point. We know that if this is a speed v0, when 2m is moving here with a speed v0, and in order for the part m to come back, it has to go back with exactly the same speed v0, because what is the mass of this body is irrelevant. It may be 10 kilo, it may be 100 kilo. If this comes back by the same parabola, it should be v0. So, mass m is moving back with v0. So we can say in the beginning 2m, the whole projectile multiplied by v0, and it gives us initial momentum before separation. And then after separation it would be mv1. M is that will move here forward with v1, and I immediately draw v1 longer than v0 because it's kind of obvious. And you will see now why. Minus, and I put minus because I know that the second part is moving back with the speed v0, and that's it. And this is the law of conservation of energy, of momentum. The law of conservation of momentum along this, and physics almost is done, it's mass. I can cancel m is the same factor, I can divide into m, but it's kind of obvious that I can cancel m, and I have 2v0 equals v1 minus v0, right? And what that means? That means that, let's find v1 and move it there. It would be 3v0 equals v1, v1 equals 3v0. Alright, so I know that this v1 is 3v0, that's why I draw it that long, and of course it's obvious for me because initial momentum was this, and then part of momentum after the separation was directed this way. That means that this has to have fairly much significant momentum in order all of this should be valid. So this is directed this way. This has to be big. And this will be big only if this v1 is 3v0, then everything is kind of the same. And all they're asking us where this will land. Well, think about it. We have this parabola. Everything in this direction is h is gt squared over 2. So this is a free fall along this line, and there are no initial speeds, so this chard will be falling down in this direction, and it will take t, time t, and the same for this chart, for this particle that moves forward with the speed 3v0, it will be the same time before it falls. So basically the picture, if I will draw it to scale, would be x, y, this flies here, this is a parabola, then one chart comes back, but this moves 3 times bigger speed. And if it moves 3 times bigger speed, the parabola is stretched here 3 times. And of course, during the same time, this will cover the distance L, and this will cover 3L. So it will cover 3L, so it will, the whole distance would be 4L, 4 lengths. And basically that's it. They ask us where it will fall, and yes, it will fall us 3 times the distance from the original point to the apex. And it doesn't matter which is the speed, exactly what is the number of the speed, 10 meters per second, 100 meters per second, 15 meters per second, and that doesn't matter which mass, 10 or 20, as long as it's separated in 2 equal pieces, right? One piece and another piece. And of course, if it's different, then it's all details will be changed, and then we will have to know what are the masses. But in this particular case, we know that it is 3 times longer. This body will cover 3 times more distance horizontally than this body. And this is only because its speed is 3 times more. I hope you liked it. If so, don't hesitate to put a like. Don't hesitate to subscribe, put the bell. Have a question? Ask it. Thank you. Bye.